we can start in our final lectures on sustainable biotechnologies, and mostly we need set moment conclusion for topics that we discussed later, discussed previously. For example, we have such topic, biotechnology in human life, bioeconomy, intensification of anaerobic digestion of wastewater, sewage sludge, analysis trends of this, modeling of biofuel production, climate change adaptation technologies. These topics we done, and also we need to, how to say, summarize this knowledge. And for this, I want to provide some type of interactive questionnaire. I hope all will be work. We try do this. You see QR code. Let's try. Do I give you time? We have time because we need how to say this lectures. We do how for mostly involving you in you type of knowledge to see how it's useful, interesting for you, and some type of communication very important. Okay, I see. So now we see difference, a type of definition, thinking about bioeconomics as economics which use renewables, connection with application of resources use, and sort of type of branch of science, that integration economics and biology. For the sole purpose, creating theories for the better job of explaining economic events using a biological basis and vice versa. Yes, in general, mostly all have connection between each other, these definitions, the thinking, and we can tell it's really correct, but should be mentioned, start to summarize this definition, that bioeconomics, it's a really type of economics growth in society that based on different type of bioprocessing, that implementation in industry for the production a lot of useful bio-basic products for us. So basis for bioeconomics is biotechnologies. In difference direction biotechnologies, we tell about color biotechnologies, you remember? Yes. And of course, in this type of developing biotechnologies, remember color biotechnologies, medicine and pharmacia biotechnologies, yes, agriculture biotechnologies, industrial application of biotechnologies, food biotechnologies, aquatic biotechnologies, environmental protection biotechnologies. It's really covered a lot of application fields and production, a lot of products for us, and we really use these products in our life every day. Okay. We can go to the next pool. Food, probiotics, biodiesel, biogas. Okay. Food, it's at general food. You can, how to say, identify example of food that we use every day, or we drink every day, eat every day. Wine, beer, for example, or we eat cheese, some other products, a lot of products. So we use every day. It's really biotech products. About probiotics and antibiotics also, and vaccine, different type of biological active nutrients, vitamins, hormones, also some type. It's also biotechnology production. And of course, bioenergy, we see some example, biodiesel, biogas. It's also biotech products. Really necessary systematization, all knowledge that we have after 2 days, very intensive lectures, a lot of information. So it's a good summarize this knowledge and to see how we mostly understand this knowledge, interested in this knowledge. So let's do the next. I also input a link to our join chat questionnaire. It is okay. Posted, and also sharing my screen with QR code. Let's try do this. Okay, it's the next. Cool. And first question, what is this biogas? And it will be good that you write composition of biogas, because what is this? Or how we can use this biogas. So we see it's renewable that produced when organic matter such as food, animal waste is broken down by microorganisms in the absence of oxygen. So in anaerobic condition. Okay, waiting, maybe some other can write. About landfill gas, yes, it's a type of biogas because it's formed in an anaerobic condition in a municipal waste water landfill. But most important that should be know about this, it's a composition, and mostly we can estimation one more. Please, thinking, what is the composition of biogas? Is because we can use biogas as natural gas. So it means that in composition of biogas, we have some components okay, yeah. Gas produced by hydrogenomethane fermentation of biomass. So biogas composition, it's a methane. It's around 50% methane. So we tell about natural gas. So it's analog of natural gas. Of course, they can have hydrogen, but mostly not a lot. The next component is CO2. It's around 35%. And of course, it can be some of impurity, some of not useful components. It's a hydrogen sulfide and ammiac. That should be purification biogas from these components, and mostly upgraded biogas to methane. When we get methane, it's mostly analog natural gas, and we can use as a source of energy for our purpose consumption, energy consumption. So it's an compositional biogas, and of course it's a production biogas connected with anaerobic digestion, and terminal state of anaerobic digestion is a methanogenesis. Methanogenesis is a methane production. Okay. The next we can go. Okay, yeah. What is a digestate? Also, it's connected with anaerobic digestion. Anaerobic digestion, we can get biogas is a basic products, but also we can get other type of basic products. And this is also products that we can get from anaerobic digestion. And what is this material? It's very, how to say, general. How we can use, how we can get, and mostly what is this? Because materials is a very, very general term. A lot can be material. Can specify, please. Mm-hmm. 10% right. It's very interesting type of material that we get. So we have sustainable feedstock that go to anaerobic digest. Sustainable feedstock, it's mean, for example, different type of organic waste go to anaerobic digestion. Some very useful group of microorganisms, especially methanogenetic microorganisms, provide transformation of these materials. Yes, please thinking about this. Okay, and after this transformation, this fermentation, organic waste in anaerobic condition with our microorganism, we get biogas is a gas phase go, it's our biofuel, and we get solid and liquid phase of digestate. And what we can do with this digestate? Mostly it's very suitable nutrients that can be used in agriculture as organic fertilizer. So digestate can be very useful as organic fertilizer. And we get digestate after anaerobic digestion? Okay. So we can go to next question. What are the state of anaerobic digestion? We tell a lot of anaerobic digestion, and I also mentioned about dark fermentation, and we tell about this state for transformation, this organic substrate. For thinking about this, so, I see some person write very quickly. And we see the state, hydrolysis of complexes or organic components for more easy biodegradation components. In acidogenesis, it's also release CO2 and organic acids. And then acidogenesis with acetate get, and soon terminal final state is methanogenesis. Then we can get methane. And also, it's a most important state for get very good quality of biogas, because methane is mostly important energy resources. Okay, so we identify this state of anaerobic digestion. Maybe some person want some edit for this. And every of this state involving different group of microorganisms. They step by step, how to say, using these processes, because it's very important that metabolic activity each groups in different trophical connection. Okay. We identify the state of anaerobic digestion. Thank you. Thank you. And we have also the next type of our small questionnaire. I give you also link in our chat, and also sharing my screen with QR code. You see screen. You see a QR code. You see also link in our chat. And first question, what element of biotechnology do you know? Is this question connected with our first lectures? Because if you remember first presentation with information, what is biotechnology and how it's important in our life. And we also discussed elements of biotechnology, what is present, and I tell about these elements and how it's connected between each other together. Elements, it's mean, for example, how to say, biotechnology, we have biological part and engineering part. Yes, we need some equipment, some apparatus, equipments, some technology. Yes, and about biological part, it's also can be different groups of microorganisms, for example, and we need for this microorganism, for this biological agent, some of substrate that eat these biological agents, and soon under metabolism we get some useful products. Remember, it's a general elements of biotechnology. Please thinking about this. We have time. So I can give you some more, how to say, information for refresh our memory. So elements, equipment, bioreactor, fermenter, and some other equipment for purification products. This is element for biotechnology, difference biotechnology, difference of application industry. So engineering part, equipment, bioreactor, fermenter, yes. The next part is our biological agents. Without these biological agents, we cannot tell about biotechnology. Our, how to say, producent useful products. We need substrate. Substrate also element of biotechnology, and substrate can be different. For example, for environmental protection system, for biogas technology, it can be possible use as substrate for microorganism growth, different type of organic waste. Yes. Also, we need all automatization, this system controlling parameter, and this stimulation, yes, that help to control and monitoring all processing. It's also very important. And we get some products, basic products. And we will tell about these basic products, biotech products that we can get. It can be different according to the technology, according to the branch of biotechnology. In medicine, it can be antibiotics or probiotics, hormones, yes, different enzymes. It can be possible in biogas technology, biogas, yes, digested. Also is as products that we can get. So it's really depends of biotechnology and application of biotechnology. Very different can be products, but it's mostly metabolic processing and the metabolic processing of some microorganism. We can get these products, and also it can be biomass of this microorganism also as products. So it's elements of biotechnology. The next that we can go, what types of biofuels do you know? Mostly I think it's for you very easy question, because previously we discussed this type of biofuels. So please write your opinion. We know that biofuels can be liquid, gases, and solid fraction biofuels can be. We mostly tell about some type of biofuels previously. It's a final two questions, and then we go the final topic today. Okay. Biogas, it's a biomethane, biohydrogen, can be solid, it's a pellet, for example, when we tell about biomass pyrolysis processing, liquid, biodiesel, for example. So we can mostly tell about different type of biofuel and different processes of fermentation that involve in to conversion biomass to get this biofuel. Different generation of biofuel we discussed it previously. So you can think more about this. Ethanol and biodiesel, yes, it's correct. Animal waste, how to say, it's not that, it's a feedstock that can use for production biofuel, but it's not directly biofuel. Animal waste is a feedstock for production biofuel, can be. So note some moment of this. Okay, thank you. Thank you for your activity. And the final question, what sustainable development goals can be realized using biotechnology? And you can see these sustainable development goals. For example, what we can to see that interesting for us, climate action. Yes, its connection with biotechnology, reduction of greenhouse emission, responsible consumption and production. When we involve it sustainable feedstock, we involve it waste to recycling in bioprocesses and to get useful bioproducts. So we valorization this waste, and we minimization use natural resources. So it's also connected with these goals. Most life on land with connection of ecosystem service, sustainable developing agricultural, and also we have application in biotechnology for soil remediation, etc., for food production. So it's also connected. Good health and well-being in medicine biotechnology very quickly grows, and it's really connected with this industry, innovation and infrastructures. Yes, a lot of biotechnology have innovation part, and suppose grows some bioproduction plants in the world. Also about when we tell about economic growth, bioeconomics connection, about clean energy. It's a sustainable development goal 7. We see clean energy. It's a renewable energy. For example, biogas. Yes, it's connected with this goal also. With these goals. So we see this United Nations Sustainable Development Goals, and we really see that biotechnologies covered a lot of these goals, and mostly bioeconomics really have very huge interest in the world, because it's mostly a sustainable type of economics, circular economics, that provides that environmentally friendly approach for human life. Okay, so we analyze this, and it's that summarize all information that we get from last 2 days. And now we have final topic. I share in my screen. A moment. Okay, I'll try sharing my screen now again. Okay. Restoration of bioproductivity of radiation-contaminated soil. Also, it's connected with different type of contamination. We discuss in today process for radionuclide migration into the environmental nutrients, some natural process and human-made sources. Some of type of deactivated or radioactively contaminated territories, implying the different biological methods. Also tell about Chernobyl biosphere reservation and some of mechanism of restored Fukushima danger evacuation zones, some of biopreparations that can be used, and matrix materials for the nuclide fixation. We also discuss some part very briefly, and method of restoration of bioproductivity of radionuclide contaminated soil. Also, type of opportunity for this we discuss. So it's topic of today. Mostly also we can tell about some of these chapters more deeply if you want, but let us see. If you have questions, additional questions, you can tell me, you can write me any type of communication that's suitable for you, you can use. Also, of course, we have natural background radiation, and it's mostly radiation that we feel every time in our lives. That natural background, it's mostly connected with such pyramidal radioisotopes that present in land and us. But mostly it's interesting for us discussion how our sources, man-made sources of radiation, impact on our life and this connection with the different opportunity of use radiation in medicine uses, for example, in industry use in radiation, and of course it's a nuclear power plant. Most radioactive waste are generated by nuclear power plant, and of course it's that of dangers of accidents that can be in nuclear power plants. About naturals, we mostly know also that some of general composition of our natural radiation elements and artificial radiation sources very different also, and there can be comparison in the different type of industry. How it's involved to use radionuclides, and also how it can be involved to our life also with these services. Mostly, it's a lot of researches that tell about migration processes of radionuclide in the ecosystem involved in this process in biochemical migration, other elements that connected air, water, and soil in one system, especially such dangers of this migration can be discussed accordingly some accidents in nuclear power plant, different type of explosions that can be possibly involved a new type of contamination in general, and also this standard contamination that can be long-term of impact, not only human in life, but it's a impact in genetic level for new generation of people. Mostly, also we can analyze this different type of decay. Radionuclide decay, it's at physics classes, and how it's impacted on human. And this most information given in such type of refresh our reminding about this. And also for us in general, a lot know about Chernobyl exclusion zone, and it's mostly interesting how it's developing in general as a biospherical storage, especially a lot of discussion organizations is on and how it's developing and also important development nowadays in wartime challenges. In general, we have such researches that comparison how radionuclides and heavy metals migration is on radioactivity contaminated ecosystem, how it's developing the system, biodiversity of the system, and they go to natural ecosystem condition. So in this way, also important analysis possibility of contamination different component of ecosystem, radionuclides, and the trophical change to human body. It's integrated to one strategy of sustainable development Chernobyl biosphere reservation with cooperation with researchers, education institutes, improving area management, and involving some innovation technologies that involve in such international cooperation in this field for sustainable development in this territory. As an example, it's a Fukushima accident in Japan. Also, such example give new experience in this field and how to locate it related to this type of contamination. It's a possibility to organization different areas and buffer zone of this territory, and mostly it's connected with evaluation some equivalent doses and under all of this type of accidents that should be mentioned about growth interesting of method of restoration, about productivity of radioactively contaminated soil. Some part of this type of method uses in complexes, not only for radioactive contaminated soil, but other contamination also. And it depends of the condition and of this territory and complexes approach. Mostly also should be mentioned that this type of methods often used together. It depends of condition situation. For us, as we how to say focus it on biotechnologies, we also need to discuss how biotechnology can be useful for such type remediation, soil remediation. And method of bioremediation connected with the use metabolic potential of different biological agents and enzyme technologies also. And mostly it's also combined with different matrix composites use. And depends of devoted radionuclide contamination territory of different zones can be used different methods. About biotechnologies approach, we can find a lot of such research in the databases corpus and the Web of Science. This approach involves different type of biological processes that can give us some fixed of the radionuclides. For example, absorption by absorption, by accumulation, by mineralization processes, by stimulations, using for fixing radionuclides and site of conversion. This type of harmful components, and mostly it's also covered by a different condition, also anaerobic transformation and aerobic condition. It depends of process that we use. And you see presented, for example, description of enzyme reduction and indirect mobilization of radionuclides by metal reduction microorganism, and this mechanism of direct enzyme reduction and direct enzyme reduction was using metal reduction microorganism. So its set of mechanisms can be useful in bioremediation, radionuclide contamination territory, and also this biological approach involving together with other type of approach of purification. For example, this combination can be covered by long term of reservation this territory, or how we can estimations of opportunity for next use this territory. Improving bioabsorption processes, some possible to stimulation growth microorganism also requires some substrate involved in nutrients, some condition of contamination soil improving to check pH, some opportunity of using immobilization carrier, mineral carriers that can be effective also. In general, we can devote its biological method using different type of biological agents according to, for example, enzyme technologies, phytoremediation technologies, some microbiosaturation groups that can be useful for bioabsorption, bioaccumulation processes. Also, often now differentiation of biochar use. We go to biochar more later. Radionuclide tolerant bacteria, also investigation genetic modification of this type of bacteria is one direction of research, and a lot of type of research combination of absorption heavy metals, contamination soil and radionuclides, using macroanalogs of radionuclides for this also. And different species of microorganisms can be used. I can see some of groups of microorganisms and some of contaminations that can be covered by these groups of microorganisms, and mechanisms that involve biomineralization, bioaccumulation, biotransformation, and bioabsorption, and some type of bioprecipitation, because also it's possible to use metabolite activity of this microorganism and use metabolite from these groups to precipitation some of radionuclides and heavy metals and fix it in some forms that cannot migrate it in ecosystem. So it's the most important stop migration of this radionuclide in the ecosystem in general, fixing in some sustainable, some stable form. Also, we can tell about in situ exit bioremediation that involve different techniques, and it's possible to use some biopreparation in soil, that contamination, and it's possible to take, for example, the soil and have some separate processes in some bioreactor equipment used for this. And mostly it's that bioremediation techniques can be used in bioreactors, for example. It depends of volume of this contaminated soil and how we can process it in location, in logistics, infrastructures, this type of method of bioremediation. Also, different type of matrix materials can be used for radiation fixing. And it's also important combination biopreparation and matrix materials together for more stable fixing radionuclides. And a lot of different type of materials used for this, and a lot of research focuses how the structures impacted absorptions, activities, and etc. A lot of materials now as using natural materials and using synthetic materials, minerals, different type of minerals using for bioabsorption, and different engineering techniques support this for bioremediation processes, large bioreactors that can be used input soil and nutrients in mix it, and large reactors that use stable groups of microorganisms for type of purification fixing radionuclides, or some type of bioventilation system of soil. Other approach also use different type of minerals matrix, but it's from sustainable feedstock, for example, biochar. About biochar, we can get biochar from pyrolysis, biomass pyrolysis, and it's interesting products they can be used in different way, and this research involving biochar for several direction. For example, it can be used as addition for improving biogas production in aerobic fermentation processes, and also it can be used directly together with the digestate for absorption organic, non-organic pollutants and reduction of their mobility in contaminated soil. In this way, also interesting use biochar for binding heavy metals and radionuclides. And mechanism of this binding fixed precipitation, a sum of extract, ion extract complexation, as it can be connection with features of biochar, a lot of discussion and investigation and different research. And we can analysis of this type of investigation and see that of active progress in this type of strategy of using biochar. And mostly mechanism can be devoted for ion extract, electrostatic interaction, power filling, hydrogen bond and functional groups interactions that can be useful for fixing radionuclides and heavy metals. And this biochar is, I mentioned, is products of biomass pyrolysis, can be used together with biopreparation with useful groups of microorganisms that can be provided by accumulation radionuclide, and also involved complexes approach to bioremediation. Features of biochar can be very benefits for this. It's a high absorption, with contribution to elimination excess substance from the soil composition, and also slow down during root system of plants. Parasites, it is useful saturation of nutrients of soil. Chemical inerts also, it's very natural materials. So it's all type of features can be useful in bioremediation processes, and mostly when we comparison some of facts from remediation soil, should be mentioned about different way and approach. As a connection, for example, with aerobical conversion with digestated and biochar based on biocomposites that can be used directly in situ in soil. Reduction exchange form of heavy metals and radionuclide available to plants. Use of secondary resources such as stock sustainable for soil purification. Anaerobic digestation in organic waste, for example, is a digestate, yes. Stimulation used in different stimulation, how to say, grows soil biome. It's useful microorganism in soil that's very important for covering territory. Fixing radionuclide in the stomatic structures and reduction migration to groundwater. Also, when we tell about food phytoremediation, it's also improving pH balance of soil, phytostabilization, filtration in order to reduce radionuclide heavy metal migration into groundwater. Also, important certain complexes integration approach for biological methods involved to processes remediation soil. And mostly in this way, it should be mentioned that a lot of investigation now tell about opportunity of remediation soil, contaminating different type of pollutants, and mostly it's a very target issue, a very target questions for soil in Ukraine. And it's really necessary to provide such type of approach, complex approach to help do remediation soil that suffered now under the war, and complex approach involving the chemical, physical methods of improving quality of soil. It's important, but biotechnologies and bioremediation methods, it's very important for soil recovering and to how to say, provide such a natural mechanism of soil biome growth, and mostly it's important to gamification processes and long-term processing of recovering. So bioremediation technologies, it's mostly environmentally friendly technologies for recovering different type of soil contamination. And now we briefly tell about such type of contamination that it can be involved in soil. In the radionuclide contamination, very dangerous. We analyze some of mechanism. Also, we have time. I try arrange some of information, more information about using digestate, because I see it's also topic with connection with opportunity using complex using digestate in a method of recovery in our environmental and different opportunity of these processes can be involved. And I think we can have some short, brief detailization of biological method removal emergent contamination from the environmental as addition for topics that we discussed previously, and have some short questionnaire also. Okay. So it's mostly connection and deep analysis opportunity biological method using for some of purification environmental, and we mentioned about biotransformation, bacterial degradation, some microbiological method for removal pollutants from environmental, and a lot tell about emergent contamination, that really different type of components can be involved. Now it's mostly new definition of term of emergent contamination include chemicals and biological contamination without a clear definite regular status, and the connection with human activity, a lot of type of activities. And now to this system of type of sources of different type of super harmful substance from industry and domestic. We can also involve it input a big part of type of that contaminations that involve enduring warmth. Example of biodegradation pollutants you can see also in this slide. The connection with hydrocarbons, different type of polycyclic aromatic hydrocarbons that involve different synthetic organic chemicals also, etc. And mostly sources of pollutants very different, and it's connected with human activities. Also, it should be told that biotransformation processes use a long period of time and involve some of nature's mechanisms that microbiological metabolism that can be useful for this process, and as such, biotransformation, bioconversions. We use some enzyme biocatalysis system also. And techniques, such as environmentally friendly techniques that have some advantages comparison with chemical physical methods, but mostly it's prefer used together step by step. It depends of critical importance to reduction impact of such type of pollutants in environmental and step-by-step recovering this environmental, mostly critical accidental type of impact should be minimization using some chemicals method, but when we tell for restore it for recovering, it's mostly about biological methods. And mostly we tell about complex approach that involve not only one part of ecosystem, but soil and water and air together, because all of this component is all of connected in ecosystem. So we can more deeply analyze some of approach biotransformation, the biostimulation, augmentation that also uses, and different type of microbiological investigation and biotransformation of pollutants done now. Analysis is isolated these microbes, and so using estimation and biotransformation potential is very important this way, and also some laboratory experimental monitoring as the optimization condition of this biotransformation, and soon some field application in situ can be or ex situ that we tell about this method previously. Also, most important to analysis how it can be implementation in the field. So bioremediation have different techniques that involve different engineering equipment also, and involving of course enzyme technology and big part of genetic technologies with field with microbiological investigation also that can be suitable connection with possibility of using a sustainable feedstock for this type of remediation, and a lot of reporting for opportunity of use a different type of microorganism. For this, we can find is publication activities in this field. Some of them you can see present in the slide with links for these researches, this publication. And the two processes that are very important for transformation, different type of pollutants. It's involved as dissociation, acetylation processes, as it can be reflected to microorganism metabolism for processing absorption in releasing form and absorption in bound form. This is connection with different approach of biotechnological degradation, different type of pollutants, and the activity of growth, useful groups of microorganisms, and how we can support these groups of microorganisms, activated these biological agents for a more effective transformation, bioabsorption, biodegradation, and different type of substrate, and to go of more friendly way for this process. Also, it's possible, for example, when we tell about microorganism, that developing a lot protection mechanism from different toxicants that can be used as this mechanism for processes by remediation. In other way, different type of factors can be impacted for a microorganism and their processes biological purification ecosystem, and these factors can be devoted for that type of biotic and biotic factors. Of course, temperature, moisture, pH, some other ultraviolet radiation is impacted for growth bacteria, growth different groups of microorganisms. Also, biotic factors is mostly enzymes, biosurfactants that can be used, and mostly it should be mentioned when we tell about biopreparation, a lot of use immobilizing carriers that can be helpful for microorganisms to be strong in the environmental, in aggressive mediums that it can be input for activation, the mechanism by degradation, by absorption of some pollutants. This also mention about processing phytoremediations and how it's reflexive to use in different type of plant. Nevertheless, it's mostly symbiosis plant and some of groups microorganisms in rhizosphere also important. About degradation, when we tell it's mostly broken organic matter of organisms, of bacteria, fungi, and others. When we tell about bioremediation of uses, some natural processes, the liberal introduction of microorganisms to consumption, to consume some pollutants, and purifications as components of nature's components. And biodegradation is mostly nature's process, and when we involve in this nature's processes to method of biological remediation, we go to engineering part, and it's mostly faster processes that improve and cleaning out environmental pollutants, mainly that made of sources from human-made pollutants, and it's a lot of type pollutants can be discussed, not only heavy metals, not only radionuclides, also new type of emergent contaminations can be discussed. A lot of investigation now connected with microplastics and how it's affected of plant performance, how it's impacted for soil microbiology community, and it's really such new issue for direct toxicity or indirect impact of soil structures and water holding capacities. So it's different investigation of this type of contamination also, and our connection with opportunity of potential impact of that type of pollution and how it's involved to carbon and nutrient cycle, biochemical cycle of transformation using bacteria. This is also type of contamination when we tell about biodegradation, but fragmentation of such type of pollutants and opportunity for simulation and mineralization. It's one of type of investigation of this process and that we can see also bioremediation of petroleum oil, hydrocarbons. It's one of the important type of applying of bioremediation using different type of preparats that have such groups of microorganisms that can do this, and mostly by degradation of petroleum oil, and to get such products as CO2 and biomass growth. So it's also very important part of investigation. And when we mentioned previously about biochar, also biochar had different type of application, and absorption activity of biochar and opportunity of support biofilm growth using in processes of bioremediation soil. And a lot of investigation in this field we can see now. Yes. It's a complex approach that involved different ecosystem components. When we tell about soil, we also tell migrations as pollutants to water, groundwater, and soon to river and sea. We tell about impact air contamination also, and how it can be reflected to general biochemical cycle for migration, different type of pollutants. And the bioremediation approach can be used in different way for this type of contamination. And now, such a shortly introduction is this very vital topic. I also want to provide some questionnaire for analysis all of this, how to say, information, to sort this information, systematization this information. And we have some short-term questionnaire. I also copy link input to our chat. And sharing my screen, and this screen you see QR code. It is also important part of our work together, because a lot of information, and we need some of this information systematization for ourselves. And in such conversation, we can do this very carefully. What is this bioremediation? How you understand this term? It's your opinion. It's depends what you thinking about this. It's not necessary to find some definition, but your opinion will be very good to know. Bioremediation, biological part, yes, and what remediation. third question, if you have some how to say technical issues, technical moment, please tell me. If you need some more information about bioremediation, tell me. I can more deeply tell about this, that covers this topic more effective. If you need time for thinking, I can give you time. The most important that we understand this topic, mostly some of basic basic aspects. Yes, we see using some biological agents, living organisms, such microbes, bacteria, and etc., for removal of different type of contamination in soil, in water, in air, so in all ecosystem components. Okay. Maybe some other have some opinions also can be added. Purification, soil and water using biological organisms should be mentioned that bioremediation can be used not only for soil and water, but for air also. They have possibility purification different type of gases, steams, using biofiltration and biofilter with immobilization use of a group of microorganisms, bacteria. Through it go these gases, and we can purification, for example, from hydrogen sulfide and other type of harmful components. So it's use, how to say, not only for soil and water, but for air also can be used in general bioremediation. But we focus today in soil application mostly, and water application also mentioned. But in general, all covered ecosystem components. Any other opinions? So we fix it in this type of definition, and mostly it's okay, but I hope some other person also can edit some opinion, some thinking. Mhm. Mhm. Okay, we're waiting. Mhm. Some more opinion. Okay, because it's really different opportunity can be discovered in bioremediation, and mostly restoring to different living organisms can be used for this. It depends of some methods that we can use, basically a lot of more popular, how to say, methods of use microorganisms, different type of bacteria, fungi. For this, also use it phytoremediation, different type of plant. A lot of these groups of microorganisms use and living organism in this way. But of course, we can, for other type of bioremediation processes, not a lot of using, not frequency using. But when we tell about bioremediation of soil, of course, it's the most basic different groups of microorganisms, bacteria, fungi, and also phytoremediation, so plants, for example. What biotechnological approach to bioremediation territories contaminated with heavy metal or radionuclide do you know? Biotechnological approach to bioremediation territories contaminated heavy metals and radionuclides. We tell about this. You can think in what we tell. We tell about different mechanisms, biological mechanisms that can be used. About tell about biosorption, bioaccumulation. I think discuss a lot of this type of biological mechanism and how can we involve different groups of microorganisms to these processes. So it's mostly basic on biological mechanisms that use for bioremediation. And this biological mechanism connected with some natural mechanism of protection. Microorganisms, they have this protection mechanism against some pollutants. And we can use this mechanism as biotechnological approach to bioremediation, involving some engineering part, involving some of part of techniques to apply this natural mechanism protection, biological protection to a more big, how to say, implementation in territories that contamination heavy metals and radionuclides. Thinking about this. And also the next question, what is a biochar? I think this question is very easy. I tell what is this biochar also, and mention for production biochar we can use sustainable feedstock. Please check this type of materials. What is this materials? Any thinking about this? You have a lot of opportunity to search what is this biochar, and also I mentioned in my lectures what is this biochar. So I give you 5 minutes, and then we discuss these 2 questions more deeply. What is this biochar, and what's the biotechnological approach for bioremediation, soil contamination, heavy metals, and radionuclides? You know, so we discussion to these questions more deeply. So as I mentioned, we can get this type of products from pyrolysis of biomass. Can be tell is a such form of charcoal. Most of all, it have very good sorption features. So it's useful in remediation processes as matrix materials. Some other opinion or some additional opinion? Let's see. And also this big question for us. Okay, so we can mostly two questions we done, and one questions we need more deeply analysis. Okay, I think we can return to our lectures materials. And some mention more focus under this approach. We can go from these slides. So when we tell about biotechnological approach to remediation of soil contaminated with radionuclides, heavy metals, it can be complexes contamination. We tell about nature's mechanisms that have microorganisms for protection themselves from this type of pollutants. Bioabsorption, bioaccumulation, and biostimulation. It's the basic. We can also discuss in others some of branches that can be also devoted this type of mechanism, but mostly for such first introduction, it's enough to understand this mechanism, bioabsorption, bioaccumulation, biostimulation that use in for remediation soil as biotechnological approach, because it's mostly basic on this mechanism. Especially we can also additionally tell about enzymatic techniques that involve into this process and about influence conditions of treatment. When we input, for example, their preparation with useful groups of microorganisms to soil in situ, also we can input some nutrients, some type of medium that would be support as microorganism to adapt to this type of condition and more effective growth biomass and metabolic activity stimulated that can be useful for realization such type approach, bioabsorption, bioaccumulation, biostimulation, and to effective mobilize radionuclides to fix it. Yes, to reduce migration of this type of harmful elements, dangerous components in environmental in ecosystem. So, basic to understand this approach, but technological approach, the basis of nature's mechanism of protection microorganism from this pollutants, and this nature's mechanism, biological mechanism, we apply to techniques realization in biotechnological solution. So it's the most basic way, how to say. In As a more deeper analysis, we can discussion a lot of bioremediation methods, techniques, and covered a lot of biological agents that can be involved to this. And also when I mention about biotechnological solution, it's such a long-term restoring and long-term recovering soil, and very helpful for overall sustainability biome of soil. It's important for recovering potential, biological potential of territory. So it's an environmentally friendly approach for treatment contamination soil, and its uses integration to the physical, mechanical, and chemical techniques for emergently involved into the territories with accidents, some accidents, contamination, and soon we use bioremediation techniques. Okay, so this moment we fix it for ourselves, yes, for understanding. The basic moment, of course, if you don't have background in this field, it's not easy. But in general, for understanding these processes in environmental and understanding is a target, how to say, a target should to provide some techniques for remediation, soil remediation, ecosystems, because it's deeply important for human health and for new generation of people, because we as a part of ecosystem and all of this type of contamination impact to our health in long-term impact. It's mostly this approach help reduction harmful long-term impact for our health and for new generation of population. So it's a basic moment for this topic. This topic mostly very complex, not easy, but it's nowadays very important topic, and now a lot of discussion how it's we have opportunity, what the type of techniques need to use for restored soil after some military activities, and it's important to understand mechanism and complexes methods that we can use for this. About biochar, we tell about biochar, so it's mostly the formalization ourselves about this type of materials, because now it's also a lot of use biochar, and also together with the start from anaerobic digestion, yes, organic waste. So a lot of potential mechanisms can be useful in processes bioremediation. So that type of matrix materials can be very useful involved into biological preparation. So it's also an interesting direction of research, and not only research in lab, but a field application also. Okay, it's a mostly basic information for today, and we finally understanding, I hope, such type of biotechnological approach for bioremediation, territory contamination, radionuclides and heavy metals, and this very huge topic and very important nowadays. We have only such introduction for these topics. To have some review of publication activity under these topics and some techniques that basic to bioremediation our ecosystem, and to see that biotechnology can really different application, and mostly we discuss the topics under sustainable biotechnology with relation to environmentally friendly approach and environmentally protection technologies processes. So it's important we tell about biotechnology as environmental protection technologies, most of all. To covering topic with bioenergy generation, production, also how it's connecting with general potential of reduction emission greenhouse, and also with action with climate change, discovering some of branch of biotechnology and how it's a basis for bioeconomic growth in the world, and in finally to see sort of application biotechnology for treatment contamination ecosystem component such as soil, for example. So it's our, how to say, conclusion for these topics, summarize these topics today. I hope this information really useful for you, interesting for you, have some new information for such type of applying biotechnology, and you can thinking about this topic. If you're interested, you can develop in your knowledge in these topics. Yeah, and how to say, now it's very important in multidisciplinary and interdisciplinary approach in research field and implementation in some practical. So biotechnology suitable for integration, different approach, integration in how mixed knowledge from different other science for support these technologies and nanotechnology, engineering part, chemical science, or all of knowledge can be useful for growth, innovation of biotechnologies, and most important to growth level of production useful bio-basic products for us, and to help to protect our ecosystem, our environmental, and our health. Thank you for your attention. Thank you that you involved into these lectures. Thank you for your activity in such a type of questionnaire. So all of this is very important, and I hope this information can be useful for you. So it's a field.
Thank you, Elizaveta, for your valuable lectures, for your information. Really, it was interesting for us. Thank you.
Thank you for your opinions. I'm glad to hear such comments, and my pleasure. And if other persons have some comments, some thinking, also you're welcome to tell. Thank you for your presence now, for your attention. Have a nice evening today, and continue the next block of lectures for other topics. It's a lot of mixed different topics. Most of all, it's a multidisciplinary approach, and you have knowledge from different type of science direction, and I think it's really very useful for grow such network. I hope it's you successful finish with these lectures in AgriSciences platforms and have a good experience for this training. Thank you. Thank you. Goodbye. Have a nice evening.
Goodbye. Have a nice weekend. Bye.
Thank you.
Goodbye.
Bye.
Goodbye.